Perfect. Again, welcome everyone. Today's topic is Ingress version 2 demo for the self-managed Kubernetes for RTF. We're gonna talk about the new release 1.10, and Amit will be speaking about and demoing us the configuration today. So we're just gonna go over a few guidelines on for this meetup. Just go over some of the rules on how you can ask the questions and eventually start the walkthrough for the Ingress V2. So this is again the online virtual English group channel. These are the organizers. I'm hosting the meetup for the Amer region along with Manik. Royston is representing, Angel is representing EMEA. So I have the privilege of talking to you all today. If you have any questions while Amit is demoing all the capabilities, please post it in the chat. So Amit will be taking pauses at the logical point. So we'll take some of the questions at that time, or we'll take the rest of the questions at the end. In case we go over 1 hour, we are willing to stay on the call for a few more minutes. All this session again will be recorded. Any questions, please feel free to go back to the YouTube channel and check out the recording. We'll be sending a feedback survey at the end of the session. If you would like to provide any feedback on the content that we are providing in the meetup, please fill up the survey. And if you would like to see Amit again with another topic, please let us know. Without further ado, I don't want to waste more time. I want to introduce Amit. He has been a resident expert in the Runtime Fabric product, and he has worked with a lot of Runtime Fabric customers in MuleSoft. So, Amit, please introduce yourself and get us kicked off here.
Thanks, Sandeep. So, hi, my name is Amit. I'm a senior solution architect within MuleSoft Professional Services. Like Sandeep mentioned, I have been working with RTF since the inception of the product, and I've had the privilege of working with various customers in various capacities. I've worked on RTF, on Azure, on AWS, even doing manual installations. And recently I've worked with the customers that had RTF on EKS. Glad to see so many of you in this. Hopefully this session will be productive for everyone.
Yeah. Amit, I'll stop presenting and you can start presenting your screen.
Sure.
Okay.
Thank you. Let me share my screen. And let me go to the presentation. Sandeep, my screen is visible? Okay, thank you.
Yeah,
so the topic of today's presentation is we will be walking through the new changes that has come in with RTF 1.10. It's majorly around the Ingress capability on RTF self-managed Kubernetes. I will be using the term self-managed Kubernetes and BIOK interchangeably. So we internally do call it bring your own Kubernetes. So don't get confused. Bring your Kubernetes is nothing but self-managed Kubernetes or BIOK. Okay, so let's get started. Before we dive more into the detail of the topic, let's talk about Runtime Fabric and what are the different flavors that we have from offerings from the MuleSoft. So currently we have two offerings. One is appliance and the other is self-managed Kubernetes. So Runtime Fabric on appliance is currently supported, or we have renamed it when we came up with self-managed Kubernetes. We have renamed it to bare metal appliance, or you can, even when you do an installation, you can see it's called a bare metal installation. So those are supported on AWS and on Azure platform. If you want to install it in, say, in probably Google Native Cloud, or even in your data centers, you can use something called a manual installation. So we do provide scripts that you can use for those installation as well. And then the most recent offering is self-managed Kubernetes, which we support on EKS, AKS, and GKE. And these are the only three places that we supported at this point. The advantage of offering self-managed Kubernetes was that customers will have now their own flexibility of bringing their own Kubernetes flavor, right? Although we say own Kubernetes, but that has to be associated with EKS, AKS, and GKE at this point. So don't get confused by that when we say own Kubernetes, because we have been asked this question multiple times, that can I take self-managed Kubernetes offering and install it in my own data center? That is not possible at this point. And customers can bring their own Ingress controller. People familiar with appliance will know that we package the Ingress controller along with the appliance, which cannot be changed. You cannot bring in, even if you want to have a different Ingress controller, you can't. And a lot of customers had this issue because of different features that other Ingress controllers may provide. So this takes care of that problem. The other issue that customers were facing was external log forwarding. We did provide the log forwarding agent with a few popular offerings that are available in the market with appliance as well, but initially we didn't have any of those offerings present. So customers were struggling with it, and they wanted to have their own log forwarding solution that they wanted to apply, which you cannot do if you have an appliance. So all those problems we are trying to solve with the self-managed Kubernetes. Customers can also now maintain the health of Kubernetes, do much more frequent updates as and when the new version of Kubernetes is present than with an appliance, because appliance, MuleSoft manages the whole appliance, so we also manage the upgrade cycle. So with self-managed Kubernetes, because of there are less moving components in place, we do plan and we do provide that as well. If you have seen the latest version, we are providing now support for 1.19 and 1.20. Kubernetes support is coming soon. So it's much more, the upgrade cycles are much more frequent with self-managed Kubernetes. Let me move to the next slide and let's see in detail what is the self-managed Kubernetes offering. So it's divided into two different components. On the top, you can see the services that are managed by MuleSoft. And those are all the offerings in the cloud, right? Endpoint platform is something which is been in the cloud. So one other question that we keep getting is, can this be managed by something which is hosted on customer premises, right? Which you cannot. You cannot do any deployments or you cannot deploy any MuleSoft apps without the help of Control Center. So all those different components that you see in the top management center exchange, all those things are provided by MuleSoft and are cloud-based offerings. Now, let's look at everything below this mark. So runtime fabric, whatever you see here are different components that customer brings in with their infrastructure. And this infrastructure is provided by Amazon, Azure, or Google, either of these three vendors that you are using. So all these offerings, and we'll dive into this component in the next slide more, are managed by the customer. And that's where the self-managed Kubernetes terms come from, including the management plane, which is managing the whole RTF cluster with the apps and the worker nodes. Okay, so let's talk about now what are the components present in any case, and this shows the differentiation of what is managed by the customer and what is managed by the MuleSoft internally. So to work with EKS, AKS, or GKE, a runtime fabric, you need to have an Ingress. Now, this Ingress can be anything that works with any of these vendors. So whatever works, you can bring your own Ingress with it. So in this diagram, you would be seeing, I mentioned about two different Ingresses that a customer may have with the same RTF cluster, and we'll dive more into it when we are doing the demo and how we can set this up. But right now, and that was one of the change that came up with 1.10, that now you can install and use two different Ingress at the same time. Now, before 1.10, when we are using the config map to set up our ingresses, even at that time, you can install, but you can only use one ingress configuration at a time. Now, that is also being changed. You can now have two ingresses installed, and you can choose when you deploy an application which of these configurations you want to go with. And one of the purposes of this demo is to show you how that can be done. Now, all the requests that comes from your application will be coming through the ingress, either of these two ingresses, which may support both HTTP and HTTPS protocols. Once it comes to the ingress via the Kubernetes management plane, those requests goes to the workers. And workers are, or worker nodes are where all the applications are hosted from Microsoft. And on top of it, to manage all these deployments, all the configurations, we have runtime fabric services, which internally is working with the following services provided by Microsoft. So we have runtime manager, which is responsible for interacting with the RTF agent. And this takes care of with some special changes that has come with 1.10, and we'll talk about it in the subsequent slides. We also have container registry, which also RTF agent talks to download any kind of images that are required to run this mule applications. So, and this is secured through mutual TLS. And then we have advanced monitoring. So each application that we deploy from Microsoft will have an endpoint monitoring sidecar. So that interacts with advanced monitoring that lets you look at different metrics for an application. It will show you, say, how much time a particular hit to the application looks like how many failures are there, how many success requests has happened, how many transactions were called, what's the CPU usage for a particular application. So all those metrics are being passed on from the endpoint monitoring sidecar to the advanced monitoring server and are visible to you through endpoint monitoring UI via endpoint endpoint.microsoft.com, right? So this is how bring your own Kubernetes different components look like. So let's move on to the next slide and see what has changed between version 1 and version 2. So internally, we call the Ingress configuration model version 1, what was associated with 1.9, which was when we are using the config map to set up your ingress. Now, so anything previous to 1.10, we call V1. And currently, after 1.10, we are calling it V2 ingress. So before V2, all the domains were configured on the runtime manager UI. So anytime you have to set up an inbound traffic, when you were setting up your RTF, we provided you an option of mentioning what is the domain your RTF applications are listening on. And then you were doing it manually inside the inbound traffic. All the values for annotations, any kind of rewrite rules, ingress class names, everything were set up using ingress config map. And the command was run using an RTF CTL utility that comes prepackaged with MuleSoft. So there were two challenges with it. One was the config map is not flexible for all kind of annotations. You will find working with various different ingresses, and that's one of the issues that we saw, because each customers, and we did give customers an option of bringing your own ingress. With each ingress that came up, there were different challenges setting up the config map. And a lot of times a customer may have to do a manual change on an ingress resource even after you have used a config map, which is not an ideal solution, because we wanted you to automate your configuration from a single place, which config map was not able to do. The second problem with this was RTF-CTL, because that's a utility provided by MuleSoft. So the customer has to rely on setting up their ingress on an utility which is managed by MuleSoft. So if you're facing challenges with your own Ingress configuration, then it was hard to figure out the issue is because of the limitation of the Ingress or because what RTF CTL can do in turn. And because of that, and this is how your upgrade will look like, right? If you have not moved to 1.10, it will show you the version and you will have an upgrade button. So this is how a 1.9 version upgrade will look like to you. So let's move to the new model that now we have introduced. Now with version 2, you are using kubectl command, which is natively present with all the different Kubernetes offerings that you may have. So it doesn't matter you're using EKS, AKS, or GK, you do have an access to kubectl command. So you are using this command to apply different configuration via an Ingress resource. So we still manage an Ingress template the same way a config map used to work as a template for all the Ingress resources that we'll create. But now you are creating that resource using the native kubectl command. From that template, and here is the changes that we brought in. From the apply template, now RTF agent can figure out that what are the different configurations that you have applied on the template, and we are bringing it up a level for the developers to see that once the configuration has been applied, what are the domains, what are the different URIs, placeholders that you have configured on your template, and those are now visible to the developer through the runtime manager UI. So once these details are mapped and you're trying to deploy an application, you can now just choose from the drop down the configuration that you want to apply on your application. So there's no more guessing. You don't have to put in your domain. There's no more going to your Ingress configuration under RTF and setting up your domains. All of those things we have taken away. And everything is now managed through the template. And once all the details are applied, you can now see that into Runtime Manager UI. You can choose that and you can deploy that with your application. Okay, now let's look into details, the different changes that that we have brought in. So now you can set up your own custom Ingress configuration using an Ingress resource template, and we'll look into Ingress resource template in the subsequent slides. It allows you to set up rules for both, say, if you have HTTP or HTTPS rules, you want to set up both. Although we do recommend that the traffic to your Ingress is secured using HTTPS. But beyond that, if you want to go with, say, from your Ingress to your application, you want to use HTTP for various reasons, you still can use that. And we'll see in our demo an example of using both the different rules with our configuration template. On a high level, this are the features that that version 2 came up with. Now, you can use multiple Ingress controllers with the same runtime fabric instance. Multiple Ingress configurations now is available to choose per application, and we'll see how we'll do that. TLS and HTTPS configurations can now be set from the Ingress resource template directly. You can now put URL parameter placeholders inside the configurations directly, and we'll see how to do that. You can also now do custom URL mapping. So in the demo today, we'll be covering all these different features that V2 came up with. Now let's see how this is done. Now, an IT administrator will be creating this template, which will be a YAML file internally. So I'm not sure if this is visible, probably it's not. I have a different view of it later on, so it's readable, but just bear with me for this particular diagram. So an IT administrator will create a template file in a YAML format, and he or she would be giving different configuration option that you want in your template. After that is done, he will be applying the template using the kubectl apply -f, the template file name command. Once that is done, the runtime fabric service will pick up the change, and that change will be propagated to the runtime manager. So the runtime manager will now know the domain on which the Ingress template was configured and various URI path parameters that is being set. Runtime manager then takes those values and makes it available for application deployment. So whenever a Mule developer goes to runtime manager UI and tries to deploy an application, the person will be able to see from a drop-down what are the URI path rule that has been set, and also the domain, and we'll be able to choose the domain. Once those are set and application is deployed, it again comes back to RTF services to figure out from the template and the values that came from runtime manager UI to create an Ingress resource specific for each Mule application. And then the Mule application is deployed. So for each Mule application, it's to keep in mind that we would be creating an Ingress resource for each and every Mule application. And that resource creation is based on the template that we have defined here. Okay, so let's go and look into detail how this template is created. Okay, so this is how the template looks like. We currently have two different resource templates. One is for Kubernetes version 1.19 and above, and the other version is for 1.18 or less than. So if customers, or if you're still using 1.18, then use the other resource template. For 1.19 or above, just use this template. So what do we have in this template? Like when you're creating any kind of Kubernetes object and you're defining the YAML file, these are the mandatory attributes that you have to set. So you have to set an API version. So this is important. So in case of 1.19 and above, you're using networking.kubernetes.io/v1. So that's the API version that you're going to use for setting up the Ingress. Kind is Ingress. Metadata, so you have to set up namespaces. There are some restrictions around setting up this namespaces. We'll talk about that. Business group and environment. So these are the placeholders, and we'll talk about the placeholders also in detail in subsequent slides. But just look at it at this point. So we have a business group ID, environment ID. So these are the placeholders. You have to mention the Ingress class name. So that comes up here, and we will look at different options of mentioning Ingress class names, because different Ingress providers have different places to mention the Ingress class. Then you can mention your TLX context here. So any host, any kind of secret that you're using, all those comes under specification. Rules for your application. So these rules can be, say, if you are doing path-based routing, right? So you are having, say, you're adding the application name inside your path so that you are able to distinguish between different applications, and you have to remove it. That's a common requirement that we see from customers, that when you have deployed an application, it's not listening on the same path, right? The application name is not in the path that the application is listening on. So you have to remove the application name. So that logic can be, the rewrite logic for your path can be mentioned here. Now, then the service name and the port. Now these two values will be replaced by the template when we create the Ingress class later. So RTF agent takes care of that. So once we have seen it for 1.19, let's see what are the changes for if you're not using 1.19. So the most the major change that comes in with the API version. So if you're using 1.18, then you have to use V1 beta 1. So that's the API version that you have to use for previous. Most of the other things remains the same. We do have the same placeholders for business group environment. That doesn't change. From rule perspective, if there are any changes for for V1 beta 1, then you have to follow those with your Ingress configurations. Okay. Let's move to the next slide. Now, what are the placeholders that are available for you? So once you look at this, you will see some placeholders have already been mentioned. So one of the placeholders that you will not see is the app name. So now app name is also dynamic. So there are 3 different placeholders that MuleSoft provides you, and these are the locations where you can use those placeholders with. So there is this app name that we will replace in during creation of the Ingress resource from the template. So in template, if you're mentioning app name, and once you deploy the application, we'll be taking the app name from the application name, and we'll be replacing that inside your Ingress resource. And we'll see that during the demo how this happens. Then there's the business group ID. So you don't have to know your business group ID. We do need it internally for managing certain stuff. So business group ID, just put in a placeholder, and we'll change it when we deploy the applications. And then there's an environment ID. Right. So this is environment ID is the environment where you are mapped your RTF cluster, and that's where you're doing the deployment. So a same RTF clusters can be mapped to various environment. So as long as this placeholder is present, MuleSoft RTF agent will internally be replacing the value with the right environment where the application is getting deployed. Now, each of these placeholders can be placed in different locations. So like app name can be put into path, host, under annotations, and under labels. So all these 4 places you can use. That's actually is true for all 3 of them. So all 3 of them can be put into different locations. If you put it anywhere else, then that will not be resolved. So that's a challenge. So how do you put that under a path name, right? So under path, you just put /app name. So this app name will be replaced in real time when the application is deployed. Same goes with label. If you want to create a label with business group ID, you can create it there, and also for the environment. So now is the time for what most of you were waiting for a demo. But before we go into demo, Sandeep, do you want to take up a few questions before we move into demo?
No, I think we can go ahead with the demo, Amit. If you want to just explain what your setup is for the demo, the cluster,
Sure.
the Ingress controllers. Yep.
Sure. Okay, so let me get out of the presentation mode and let's talk about demo and what we are going to demo today. Okay, so let me log in. So about my setup. This is the runtime fabric cluster we are going to use for today. It's an AKS-based cluster that I have created. As you can see, it's on the latest version of RTF. Kubernetes version 1.19. Why I'm not using 1.20? Because we don't support it yet. Support is coming up soon, but right now 1.19 is supported. So that's what I have based my Kubernetes cluster on. And let's look at different tabs, right? So health read is this tab will show you is the cluster ready for any kind of deployment. So you can create, manage application deployments. It looks healthy. Forwarding logs to endpoint monitoring, this option may or may not be available for you. So if you are a Titanium customer, then logs are forwarded to endpoint monitoring. If you're not, then this option may not be available. So currently this cluster does have Titanium subscription. So that's why this option is available. All the nodes are healthy. So I have a 3-node cluster that I'm using in AKS for this demo. I'm not associated environment yet, so we'll associate it as part of the demo, and we'll go through that. So what does the cluster has right now? So it's a 3-node cluster set up on AKS, which has RTF installed, and also the license is installed. So the MuleSoft license that you need to deploy application and run an application is already installed on this cluster. And that's where the cluster is at this point. So no association at this point. Inbound traffic. So no option. You cannot add any domains at this point because you are on 1.10. And we'll look at a different cluster which has not been upgraded yet. And you'll see the difference. So if you look at here, the inbound traffic option was still there, and you can add your endpoints to it if you were on 1.9. So that has changed. If we compare both of them, that has changed. You don't need to do that. Once you have set up your template, and we do give you a disclaimer that you cannot manage your endpoints anymore. Now it becomes your central IT team responsibility to set up the Ingress template, and it will be automatically, it will come here. And we'll see once we set up the Ingress, we'll see that. My cluster doesn't have an Ingress setup, so we'll do the setup of Ingress together as part of this demo. And after that, we'll be doing a deployment. We'll look at different configurations that we have to do. So all those things are covered as part of today's demo. Okay. Log forwarding, yeah, depends. If you're Titanium or not, this option may or may not be available to you. Okay. Sandeep, is this visible? Is this large enough for you to look at?
It's readable for my screen. If you just,
okay.
Yeah, it's good.
So let's connect to the cluster. So a lot of you may be familiar with controlling the cluster from probably a different, say, EC2 or a different instance that you may have inside your Azure or probably AWS, whatever cloud native solution that you're using. So you may use that. In my case, I'm using my laptop to control the cluster. I'm not using any of those options. If you're on GKE, it does give you a console. I think Azure does also have a solution to go and connect to the cluster from different ways, right? So in my case, I'm just using my own a laptop. So I have all those different utilities installed and configured already with my credentials. So probably I'm not covering that as part of the demo, but I think most of you are familiar with managing that, or it's easily available. Even if you go to the cluster and then you go to the connect option, you can see different options, right? So you can either use Open Cloud Shell, or you can just use this options here. So we have connected to the cluster. Let's run some basic commands. So kubectl get nodes. Okay, so as I mentioned, there are 3 node clusters that I have set up. Let's look at kubectl get pods -a. So I'm not doing any kind of cheating with you, and I don't already have everything installed there. So as you can see, these are all the Azure services and runtime fabric services. There are no applications installed right now. And also, let's do this kubectl get ingress -a. Do you have an ingress installed? Okay, so the ingress installed. So the first step that we are going to do is, since we don't have an ingress installed, let's install an ingress to start things up, right? So we are going to, today in the demo, we are going to use 2 different ingresses. We are going to use HA Proxy, and we are going to use Nginx. So these are very popular ingresses available to all the customers. So we are going to use that in the demo today. Okay, so let's install HA Proxy first, and let's test with HA Proxy. So I'm going to use Helm. So Helm is already installed with Brew locally. So I'm not going to install Helm again, but that's an easy command for you to follow. So let's make sure that we add the right repo for installing HA Proxy. Okay, so since I had already set up HA Proxy for my other RTF cluster, so you can see it's already there. So skipping that, let's run the helm install command. Okay, just skip. So I was missing a file. I just copied a file. So sorry about that. Okay, so HA Proxy has been installed. I will show you how my HA Proxy ingress values.yaml look like. And you can use a different option. This can be passed into command line as well. I just choose in a file. So this has nothing. We just mentioned that I'm using the controller as part of the host network. So that's an option that is required when you are trying to manage HA Proxy. HA Proxy has different configurations, which I will not go into detail of it, but that is something required to use it as a controller node, as an ingress. Okay, so we have now HA Proxy installed as a controller. So now what do we need to do? We need to set up a template for HA Proxy right? So let's run the kubectl get ingress command again and see, do we have an ingress? No. Do we have a service? Yes, we do. So HA Proxy ingress, and I've just put in the default namespace. Just you can choose your different namespace. So I'm just using default namespace for the time being. So it is being the service is running as a load balancer. I've already got an external IP for it. Okay, so we have the service running. Now we need to set up an ingress template for RTF to use. Okay, so I already have the file. Let's look at it and then go through it together. So we already saw how the template looks like, right? Now we are trying to put some real values into the template. So API version, since we are using 1.19, so that's the API version we have. Kind would be ingress. Now metadata, so we have just named it. So name is RTF ingress HA Proxy. Namespace, use RTF. Okay, so namespace, anything that you do with ingress, and even the secrets that we'll be creating later on in the demo, everything would be under the RTF namespace. So that is something that is required. Now coming to the different things, right? We talked about ingress class, and I did mention when I was presenting that there are various ways of mentioning an ingress class. So ingress class can be mentioned, and let's go back to this quickly. So ingress class can be mentioned under the spec, but some of the ingress providers that you may use may not support that. So in those cases, you may have to use this annotation. So kubernetes.io / ingress.class, and you may have to mention ingress class inside your annotation. So either you can mention in the spec or annotation. Which one to use will depend upon which ingress provider you are using, right? From which company the ingress provider is. HA Proxy supports it here, and that's the reason I chose HA Proxy and Nginx. When we do Nginx configuration, we'll see it is mentioned under the spec. Okay. when you're mentioning Ingress class, start with RTF hyphen. So that is required by the RTF agent to recognize that this is something which is meant for RTF. We do not support multi-tenant right now, but in future, if that is being supported, right, you can run along with RTF some other, say, solutions as well inside your Kubernetes provider. This will be important. So as a prerequisite for that, we have this this requirement that you have to mention RTF class with whatever English class name that you want to use. So I want to use HA Proxy, so I mention RTF class HA Proxy. Now, any kind of rewrite logic that I have with path, I'm putting it here. So rewrite target slash SSL redirect to false. We are going to use this HA proxy for doing HTTP traffic. So you can think of it as a use case where all the HTTP traffic will be going through HA proxy. All the secure traffic will be going through Nginx. So that's kind of a requirement that I've created on my own. But that's what we are trying to fulfill. So SSL redirect is false. Labels, business group ID, environment ID, we've seen these placeholders before. This is the host that we are associating with HA proxy. And we'll later see how to use this host later on. And then any path specific rule that you want to mention, you can mention it here. So we are doing implementation specific path type and app name we are mentioning here. This will be replaced while the applications are deployed in real time. Okay, so let's go ahead and then apply this configuration. Okay, so it is created. Now, how to check that it's created successfully or not? So okay, so we do have our Ingress created under RTF namespace. This is the name that we chose, and this is the host on which it's listening on. And port is 80 because we are looking at HTTP. Okay, now we have the HA proxy Ingress setup and is ready. Let's see if that change has been reflected here. So let's associate our RTF cluster with one of the environments. So I don't have anything on sandbox, so I'm just applying my sandbox configuration here. Okay, so we applied the sandbox configuration. Let's go into the applications and let's try to see if we can deploy an application. So you can see the change is already here. The agent was able to find the new template that was applied and was able to provide the host name and the path information to the runtime manager UI automatically. Now let's see if we can do some deployment in there. So we are now going to deploy what I call a ping application. So let's do this. So let's name our application AKS ping HA proxy. We're deploying in this target. Let me just take it from the exchange. So we have taken our application. We have chosen our target. We have the ingress. Let's change the memory to 1 GB. And let's deploy the application. While the application is deploying, let's clear this up. Let's run the command again. Okay. Let me make it a little bit smaller. Sandeep, is it still good?
Yep, I can see it.
Okay. Okay. So if you can see, just for this specific thing, let me make it a little bit more smaller. So maybe it's hard to read, but I will be able to show you something here. So you can see the new Ingress resource is created, which is based on the application that was deployed. The name of the application dash the name of the Ingress template that we created. So that's how the name is derived. The namespace is the same namespace which belongs to the environment where we have installed this application. And this will also match with the application pod that we'll see soon. The host remains the same. So once you have deployed the application and to confirm that the application has been deployed and the corresponding Ingress resource has been created successfully, this is what you do. You look at the Ingress resource and this is what you should be seeing in there. Now, let's see if the application is deployed successfully. Okay, so here you will see this is the application that we deployed. So we had a single replica, so one pod is running and in the same namespace as this resource. So this is done. Now let's look at the Ingress resource that got created. So okay, so this is the ingress that got created. And you can see it's already changed the path to what we have, right? So you can run this command to look at the details of this. Don't worry about this default HTTP backend error that does keep coming. So you can ignore that, but you can see all the annotations that we had, and wherever we provided the placeholders, those got changed, right? So let's also now see if we can look at the configuration in detail, right? So now you are looking at specific configuration for that ingress. And here you can see these are the annotations that we mentioned. RTF dash has been removed. So when it applies the configuration to the application, it removes the RTF dash. It just needs it to recognize it. The business group and environment has been replaced by the real values. So this is the business group, this is the environment where the application is running. Service name. So all those details, the service name here where we mentioned the app name, all those has been replaced by the values that RTF agent took it from the template. So everything is happening behind the scene. You should not be like, you don't have to do anything about it. I'm just trying to make sure that you know what are the changes that are happening behind the scene uh, in this. So once we have, let's see if the application is okay. So application is up and running. Let's try to call this application. Before we do that, one of the advantages if you're using AKS is that all the load balancer IPs are available for you to select a domain. So let's see, where did our one go? So I think this is the one that we are using, 2017, right? So let's go here and let's try to give it a domain that we can use for our testing. So let's name this meetup demo RTF HA Proxy and save this. Now let's see if the change has been done. Let's do NS lookup. Okay, so it's getting resolved. Now let's try to hit the application. So our application is named AKS Ping Proxy. It's running on HTTP. So let's test it via a curl command. Let me clear it up. So we have set up the DNS, so that's why we are using this DNS name. This is the application name. So we have done a path-based routing. So based on the application name, it will be routed to the right application. And this is what the application is listening on. This is the base path for that for this application. And we got a response back. So we now have an application that is listening on RTF AKS using HA Proxy. Let's go back to our presentation and what we have done so far. So before we started, these were the different features that we talked about that RTF 1.10 comes up with. We have now completed URL parameter placeholders. So we created a placeholder for our URL, and then we are able to resolve it. We have done a routing based on the application name. So we have done that. And also, we have done custom URL naming. So we have named this based on the meetup demo RTF HA proxy. So this was the DNS that we used, and we'll use the multiple ones. But now you can create ingresses that are listening on a specific host name, and based on that, we can direct traffic to different ingresses. Now, another option that is available to you is to use a wildcard-based host name, right? So this can also be, say, star.mulesoft.com. So that option is also available. So when you are setting your ingress, you can use that based on the host rule. We are not showing that as part of the demo, but that is definitely that you can do. So when you're setting up the rule, you can choose your domain. Either it can be a fully qualified domain that the way I chose, or it can be a wildcard-based domain as well. Okay, so we have now completed these two objectives of the demo. Now we will be moving on to showcasing how we can create multiple Ingress controllers within the same runtime fabric, how we can configure that, how we can set up TLS and HTTP as configuration. Sandeep, I think we are coming to the hour mark, right? So
Yeah,
I think we are okay to continue for a few more minutes. And we hopefully will do a Q&A session as well. People who can stay, please stay. If you have any questions, you can just put it in the chat. Sandeep will note it down. I will try to answer that. So probably you can look at the recording later and find answer to your questions. But people who can stay are requested to stay for continuation of the demo.
yeah, we'll post the recording on the meetup page. So if you're able to stay, you're welcome to stay, and if not, look out for the recording. Thank you. Yeah, Amit, carry on.
And me and Sandeep were talking about it. We probably will take more time to cover
Yeah.
everything. We did had a lot of things to cover in this. Okay, so let's do Nginx. So we'll be installing Nginx in the same way that we did it for HA Proxy. So I'm adding the repo. It's already added for me, but you have to add the right repo for you. So once you have done that, I'm going to create a new namespace. And please try to see and compare, right? We didn't create a namespace last time for HA Proxy. Now we are doing it in a different manner. So we are creating a namespace for Nginx, which is specific, right? So we are creating RTF as Nginx as a namespace in the Kubernetes cluster, and then we are going to run the hem command for Nginx. One thing to look at here is Ingress class name. So I mentioned as Nginx. Reason for that is later on when you have multiple ingresses, you want to differentiate which ingress is responsible for which mule application. So this allows you to do that. The same option can be used for HA Proxy as well, but in this case we are just specifying. So any request coming through Nginx ingress will only go to the applications where this will be applied. Okay, so we have it installed. Let's run some command to make sure that we are good there. Okay, so we have HA Proxy before, and now you will see Nginx controller has been installed as well. Okay, let me clear it up. Now, what we'll also try to do is we'll try to create a TLX to use with this. So I'm just going to use OpenSSL command. This is the name, the demo Nginx Ingress TLS. So I'm creating the cert and the key, and then we have provided a common name for this. So we got the key created. Now we need to create the secret inside kubectl so that we can use it later. Important aspect here is the RTF. So namespace has to be RTF. Please remember that. Sometimes you may face a challenge that you have created the TLS, but it's not being used correctly by your ingress. That is because of that namespace. Okay. Okay. So one name is let me make sure that I give this command properly. I faced this challenge before. So let me execute this command again. And as usual, I did a typo. Okay. So we have the TLS now created. Now let's look at the Nginx Nginx configuration. Let me make it bigger and then go through it. So API version, same as HA Proxy, kind is Ingress, give it a name, namespace, again RTF. Now, in this case, we are going to use the rewrite target. So this is the annotation that Nginx uses for rewriting the target. So we'll be removing the application name and then calling the base path. And the path specific routing will be based on the application name. That's what we have mentioned here. SSL redirect is true. So even if you're getting a HTTP, it will be redirected to HTTPS. Environment name, business group ID remains same under the level. Ingress class name, now you see, is coming under the spec. And it has to be given with RTF-Nginx. This is the domain that we are going to use for Nginx. We created this secret just before Nginx Ingress TLS. So that's what we're going to use here, the secret name. Okay, and everything remains looks the same. So let's go ahead and apply this configuration. In the meantime, I'm going to lower this a bit because we are going to run some commands now, which is going to give a lot of space. Okay, so now we have so now you can see the template for Nginx is also available under the same namespace, and it's running on a different host. So we have the template ready. Now let's deploy an application with that. Let's come out of it and let's go to applications. Let me make this bigger, sorry, bad habit. Okay, so we are only seeing one. What happened? We have both of them actually. So now in the drop-down, you can see both the hosts are available for you during the deployment, and you can choose which ingress you want. This is useful for customers that may have different business units sharing the same RTF cluster, but still want to go with their own ingress because something that they have acquired as a license before, right? Because there is a support cost associated with the ingress that you bring. So this is really useful for those kind of customers. You now see both the options available from the drop-down, and when you choose one of them, it automatically changes the path. So in case of Nginx, this is the path that we have customized. This is the mapping that we are doing. In case of HA Proxy, the mapping looks something like this, right? So let's do Nginx deployment. And what are we going to name this application? So let's name this AKS ping Nginx. And let's deploy the same file that we had, ping app. Let's change the memory to 1, make it a bit faster, and deploy application. In the meantime, just come here. Let's see if it creates a new Ingress resource. And you can see the AKS ping Nginx is being created associated with this template, and it is listening on this particular host. And it has both 80 and 443 option enabled. Let's wait for the application to deploy. In the meantime, let's do the same thing that we did. Yeah.
Amit, can you take one question?
Sure.
The configuration that you applied just now, will that also take care of make sure that the traffic is HTTPS till the application from the controller?
You need to make a small change to that configuration. So let's look at the configuration and the change that we need to do. So this was our configuration. So if you have to do an end-to-end HTTPS, right now my application is listening on HTTP on port 8081. So that's why I have not done it. You have to use an annotation called SSL pass-through. So it looks similar to this, like Nginx Ingress Kubernetes.io / it will be SSL pass-through, and then set it to true. As long as that happens, the communication between Ingress and the Mule application is secured over HTTPS.
So SSL offloading will happen at the application level, right?
At the application, yes.
And
So what SSL termination will happen at the Ingress, if you are, say, using something like a mutual auth or something. So SSL termination will happen at the Ingress, but from Ingress to application, it will still be using the secure channel for communication.
Okay, thanks.
So this is, and we can confirm this right now. So when we run, let's do this. So we need to find out which port Nginx is listening on. Okay, so it's listening on this port 52 dot this. Okay. So I'm just trying to find that out. Where's right. Okay, yes. Interestingly, that IP has not been exposed yet for the load balancer. Anyway, so we'll go with the IP out for the timing. So let me clear it up, and let's see if the application is up and running. And for cases where probably this DNS option is not available for you, right? So now we'll try to hit this application using the IP address. So okay, so this is IP address which Nginx is listening on. So hitting with this IP address, this is the app name, this is the base path application listening on, and this is the host name that we mentioned for the application. So, and we are able to hit the application successfully. So let's go back to our present, the objective. We have now configured multiple Ingress controllers within the same runtime fabric. Multiple Ingress configurations are now available to choose per application. And we set up TLS and HTTPS configurations for the Nginx. So this concludes the demo. We were able to look at all the different features that the version 2 or 1.10 is providing with the Ingress configurations right now. So I'll stop there, Sandeep. We are ready to take any questions. But before we go into that, there is something else that we just wanted to talk about on a very high level. So some of you may face some challenges or may have questions around the migration between 1.9 to 1.10. So uh, this is from our documentations. I've just put a screenshot here. So based on how your pre-upgrade configuration looks like, that this would be the actions that we'll be taking from the RTF agent perspective. So whenever you're upgrading, do keep in mind any customizations that you have done on the config map may cause issues during the migration. Highly recommended always migrate in a lower environment, test your changes first there before you move into production. Uh, but yes, to keep in mind that this is how we are translating different configurations from config map to to the Ingress template that we are using now with V2.
Yeah, I think that's very important. Thank you, Amit, for highlighting that. We have a couple of questions that came in. If you're able to take that. So one question was again, do we have flexibility on choosing the container registry?
We don't.
For obvious, yeah, and
For obvious reasons, we don't. Let me go back to the diagram. Right now, this has come up a few times. MuleSoft maintains the container registries, and the only service that can talk to container registry is the RTF agent. You have to rely on the RTF agent. You cannot choose your own container registry. Neither those images can be hosted on a customer. Uh, they have to be hosted because of the way runtime fabric is running right now. They have to be hosted on our servers.
and second part of that question was also related to observability for logging and monitoring. What kind of flexibility does this model provide?
Right. So you have multiple options here. So if you are using, say, your Titanium subscription, you can go with MuleSoft monitoring. It just you saw here that it's kind of a checkbox from your side. As long as you have configured the log forwarding, the agent will take care of it, and then you can look at those logs from monitoring, right? So going into monitoring, you can look at all those logs, the application logs. Uh, with self-managed Kubernetes now, you can you can install your own agent. If say if you're coming up with EKS, you can install the uh, CloudWatch on EKS that comes up natively, right? With and works well with EKS cluster. So you don't have any restrictions now that how do you want to manage your logs. You can install any log forwarding agent that you want, that you can want to bring with self-managed Kubernetes, as long as that is supported by your Kubernetes provider. So as long as EKS, AKS, and GK supports it, you can bring it. So that flexibility is what you get with self-managed Kubernetes. Uh, People familiar with appliance will see there is no log forwarding agent option here that you get with the appliance, and that's what we have taken that away. We with self-managed Kubernetes, we only allow log forwarding to endpoint monitoring.
Yeah. Do we have any recommendations, Summit, on the egress traffic from the cluster? Uh, what is your experience been?
In terms of what, like recommendation in terms of
Traffic going out of Mule applications to different integration systems in the backend side. Is there a way to monitor that traffic?
oh yeah, good question. So in case of monitoring, if you want to do out of the box, that is provided by the monitoring, right? So if you are having endpoint monitoring setup, then we do provide you different parameters against different outgoing calls. So anything that goes outbound, it does show that what is the response time, how many calls, and all those things. So if you have endpoint monitoring, uh, and by default, the monitoring sidecar is there with MuleSoft applications, this information should be visible to you. So I will suggest that you look at the monitoring dashboard and see if you need anything more than that.
I think the question, Amit, was like more on governance, how you can control the traffic going out of the cluster. I
Okay,
don't
okay.
think we have anything on the product side, but natively the cloud providers should have something.
Right, and that comes from the correct, and that comes from natively from the cluster that you are using. Right, you can control your traffic with the options that you get with EKS, AKS, and GKE. All three of them allows you to set up those outbound traffic rules when you're creating those clusters, and clusters will inherit those rules that are being created. So as long as you can create those rules in there, those will be followed by the RTF cluster as well. We are not outside that that network or that VPC or those networking rules that you are setting up. So
there is a question from Chi. They're asking what are the ingress classes that RTF is supporting as of now? Do
okay,
you have?
so nothing from our side. If you are using self-managed Kubernetes, as long as an Ingress class is supported by your native cloud provider, EKS, AKS, and GKE will support it. We don't
Great.
restrict you.
There is one more continuity question on the end-to-end HTTPS.
Okay.
Is there a way to do MTLS at the app, and can we pass the client cert info in that?
Yes. Much more complicated question to to give answer within this short amount of time. I will give you a short answer to it, and from what I know of, right? We do have some experts in the call as well. Somebody may have a different way out of this. So what I've seen customer do is, if you have MTLS requirement, normally you terminate that MTLS at the ingress. You can always set up the mutual TLS with the ingress that you're using. So you terminate your mutual TLS at the ingress, and then you use between ingress your applications. You use one-way SSL, right? So the traffic is still secure, and you're using SSL pass through there to do that. The challenge with the whole idea of doing an MTLS application is how are you propagating the certificate in the application? If you have an ingress in front, most of the times that certificates are lost when you are interacting with the ingress. You do have some configurations provided by ingresses to take those certificates and add them into headers. And that's what they do by default. They will not keep the certificate at the same place that you may have. So now what are the options that you may have available? Before you go into the application, before you hit your HTTPS listener within the applications, now the certificates has to move from the header. And this is theoretically, you do have to try it out. This is my point of view there. So you do have to take the certificates from the header and somehow place the certificates where the HTTPS listener is expecting it. Or you use some kind of customization. So you can create, say, a custom policy that does all of this. You take that certificate from your header, and then you inspect the certificate before you hit your application. So instead of doing the certificate inspection at HTTPS listener, you are doing it in the using the API manager policy. You're doing it in the API manager before the implementation is hit. And based on that, if the certificate is not valid, you can fail it. It no longer hits the implementation. So that's just a concept that I can put forward, but you do have to do that customization. You do have to know how you validate those certificates at that place. Has this been done? Yes, I've seen customers that have done this, but it does require customization that you need to do from your end.
Great. I think that's good info, Amit. So I don't have any more questions. Again, Amit, the demo gods were with you today. Everything
Yes,
was
fingers crossed. Yes,
so it's not
doesn't
an
always
easy.
happen. So.
Exactly. And thank you, everybody, for staying over. We're almost 23 minutes over, and I really appreciate everybody's participation and questions. again, thank you, Amit, for coming here and demoing the capabilities for RTF. You've always been a very good supporter in the community. If anybody has questions, please reach out to us through the Meetup portal, and please provide your feedback if you like the presentation today. And we'll love to have Amit again present us with another RTF topic. Thank you, everybody. Have a good day. Good night. Thanks, Amit.
Thank you.
Bye for now.